Hello students, we are solving the IB Math EA AGL past paper questions and currently we are solving the IB Math EA AGL May 2023 paper 1 time zone 1 past paper. Today we will be solving the question number 9 of this paper. You will be getting the links to all the previously solved questions of this paper and of the other papers in form of playlist in my channel NS Online Math Tutoring Classes. So without any further delay, let us start answering question number 9. The maximum mark is 7. It says the function f is defined by f of y equal to square root of r square minus y square for y greater than or equal to negative r but less than or equal to positive r. The region enclosed by the graph of x equal to f of y and the y-axis, this is the region enclosed between this graph of x equal to f of y and the y-axis. This is the region. This part, this is in fact a semicircle. This is rotated by 360 degree about the y-axis to form a solid sphere. Okay, and if you just try to get the volume of this, it will be pi and x square. So it will be r square minus y square, because x equal to square root of r square minus y square. So x square will be r square minus y square and dy, and it will be having the limits of integration as negative r to positive r, because the radius of the semicircle is r. Okay, so if you just perform this integration, you will be getting the volume as 4 over 3 pi r cube. Okay, this is the volume of the sphere that will be generated. Now they are saying the sphere is drilled through along the y-axis, creating a cylindrical hole. The resulting spherical ring has height h. This is the height h. The information is shown in the following diagrams. These are the two diagrams given, and the diagram is of course not drawn to scale. And they are saying the spherical ring has a volume of pi cubic units. Find the value of h. Now, the main mistake, the very common mistake that students do is that they are getting this volume of the sphere formed using the volume of revolution formula. From this volume of the sphere, they subtract the volume of the cylinder. They are having the height of the cylinder as h. And what is the radius of the cylinder? If I take the radius of the cylinder as this one, let this be capital R. This is equivalent to this. Okay, this is capital R. So what will be the volume of the cylinder? Of course, it will be pi r square and h. And in case we want to express this capital R in terms of small r and h, then we can do that. We have to just draw this diagonal. This is a right angle triangle. This is the right angle and this one is small r, the radius of the circle or the formed sphere, and this is h over 2. So using the Pythagoras theorem, we can say that r square will be equal to capital R square plus h over 2 whole square. So capital R square will be equal to small r square minus h square over 4. Okay, so you can write the volume of the cylinder as pi and small r square minus h square over 4 times by h. Okay, so this is the volume of the cylinder which students subtract from the volume of the sphere, and they equate that difference to pi cubic units and try to find the value of h, which is wrong. See, if you are taking the sphere, it is including this portion as well. So, and this lower portion as well. And this cylinder if you subtract the volume of the cylinder, you are just subtracting this portion. But this part and this part, they are not getting subtracted. So you cannot do this. You cannot just take the difference of the volume of the generated sphere and the volume of the cylinder and equate it to pi cubic units. That is not correct. What you have to do is you have to take this region. See, if you rotate this region which is bounded by this vertical line, what will be the equation of this vertical line? See, what is the x coordinate of this point? Obviously, the y coordinate will be equal to 0 because it is on the x axis. So, the coordinates of this point will be equal to capital R comma 0. Because this radius of the cylinder, we have taken that to be equal to capital R. So, the coordinates of this point will be R comma 0, capital R comma 0. Okay. So, the equation of this vertical line will be equal to x equal to capital R. Okay. And the expression, the function expression for this curve is of course equal to x equal to f of y equal to positive square root of r square minus y square. So if you rotate this region which is enclosed between these two function graphs, you will be getting this shape. Okay, so we have to take this, region which is enclosed between these two function graphs. One is a vertical line, another is the r. And what volume will we generate? If we rotate this portion about the y-axis through an angle of 360 degrees, we will be getting this shape, the spherical ring, and the volume of this spherical ring will be equal to, I am taking the pi outside, you can keep it inside the integration sign as well. And I am coming to the limits of integration a little later. It will be equal to, obviously, we will be taking the right hand side equation first of all. Okay, so this is the curve. So let me write this as xc square minus, this is the line. So it will be xl square and dy. Okay, so this is the formula for the volume of revolution of the solid generated while we are rotating a portion bounded by two curves or two function graphs about the y-axis through an angle of 360 degrees. We will be taking the x square expression for the graph which is towards the right side minus the x square expression of the graph which is on the left side. Okay, so it is the graph is of the curve is on the right side, so I'm taking xc square minus the left side's graph is the straight lines graph, so it is minus xl's graph, xl square. Okay, now coming to the limits of integration, you see this is what is the x coordinate of this point and the y coordinate of this point. The coordinates of this point will be equal to, the x coordinate will obviously be equal to r and the y coordinate will be equal to negative h over 2. And the x and y coordinates of this point will be equal to again capital R and positive h over 2. Okay, so because we are integrating with respect to y, we will be taking the y's coordinates. So the limits of integration will be negative h over 2 to positive h over 2. Okay, so now we will be just substituting the expression for xc which is equal to square root of r square minus y square, and the xl is equal to r. In place of r, we will be writing r square equal to r square, small r square minus a square over 4. If we take r, it will be the positive square. So therefore, v equal to pi minus h over 2 to plus h over 2, and in place of xc square, I am writing small r square minus y square, and xl square will be equal to capital R square, which will be equal to this. Okay, so I am taking this and it has to get subtracted. So it is minus R square minus H square over 4 dy. Okay, so that is equal to pi and R square minus Y square and minus R square plus H square over 4. This should end over here. Okay, dy. And this is equal to pi negative h over 2 positive h over 2, and these two will be getting cancelled, and I am having, let me write a square over 4 first because it is having a plus sign, and minus y square dy. So it is a square over 4 is a constant. So this is a square over 4 y minus y cube over 3, and the limits are negative h over 2 to positive h over 2, and I am coming to this side. Okay, so it is pi, and first of all, I am substituting positive h over 2 in place of y, so it is h square over 4 times h over 2 minus h over 2 whole cube multiplied by 1 over 3, and then minus h square over 4 times negative h over 2 and minus negative h over 2 to the power of 3 times 1 over 3. Okay. So this is equal to pi h cube over 8, and this one is h cube over 8. 2 cube is 8 times 3 is 24, so negative h cube over 24, and this one is a square times negative h is negative h cube, and 4 times 2 is 8, so it is negative h cube over 8, and there is this minus sign, so it is plus h cube over 8, and then this one is negative h whole cube is negative h cube over 8 times 3 is negative h cube over 24, and there is this minus sign, so it is positive h cube over 24, and again there is this minus sign, so ultimately we are getting minus h cube over 24. Okay, so this is equal to pi. I'm taking 24 as the common denominator, and it is 3h cube and minus h cube plus 3h cube minus h cube, and this should be equal to pi given. Okay, fine. So this is equal to pi 3h cube minus h cube is 2h cube plus 3h cube is 5h cube minus h cube is 4h cube. Okay, so 4h cube over 24 equal to pi, and I can cancel these two pi's and these also get cancelled. 4 times 6 is 24, therefore I am having h cube equal to 6, or h, I'm taking the cube root. Okay, let me take the cube root of both the sides. So cube root of h cube will be equal to cube root of 6. So we can write h is equal to cube root of 6 units. Okay. So students, we have answered this question completely. Thank you for watching. I'm Nilanjana Sanyal. I'm an online IB Math EASL and HL level tutor, and I tutor students from both within India and outside India. And I offer both one-on-one and small group online tutoring services to my students. And in case you are liking my explanations, please to give this video a like and please to share this video with your friends so that even they can get benefited by watching my videos. And in case you have not subscribed to my YouTube channel till now, please subscribe to my YouTube channel. It will be motivating me to make more math videos for you. We meet again very soon in our next session. We will be solving the next question of the same paper. Till then, bye.